Last time we saw how we can use pysimCoder for modeling and simulation. Now, let's change gears to interfacing with hardware. We'll start by blinking an LED with a digital output. Let's launch pysimCoder from the tutorials folder. And we'll navigate to the Input tab. We'll bring a pulse generator in, and we'll navigate to the NuttX tab. And we'll bring a digital output. The NuttX tab is very special. We'll use it throughout the tutorial series to interface with hardware. By double-clicking the digital output block, we can select what pins of the target we'll be controlling. At Robots5, we have two standard DACs. The EMB DAC 1 is our plug-and-play solution with an enclosure and industrial connectors. The EMB DAC 2 is an open frame version, allowing the user easy access to the board and shield. Both DACs are powered by an STM32 ARM Cortex-M7 microcontroller. The goal here is to create a useful guide, even if you don't have one of our DACs. So let's start with just the Nucleo F7 board. We plug it to the computer and verify that it's connected. The green LED is configured as GPIO 4. To generate the C code for the board, we need to change the template make file to NuttX. NuttX is a real-time embedded operating system, or RTOS. We can save the model and generate the code. To flash the code to the target, we'll open a new tab and run the following command. Flashing the code was completed. You might remember the Flash F7 script from the installation videos. Now we can connect to the target to run the code. We use a new command. We are in what is called a Nut shell. To run the code, we simply type main, and we can see the LED blinking. To stop running the code, we can enter Ctrl+T+B, B as in break. The Nut shell restarts, and we can run the code again with main. I'll stop running the code again with Ctrl+T+B. And the Nut shell restarts. To quit the Nut shell, we can do Ctrl+T+Q, Q as in quit. There's a second LED on the Nucleo board that we can control. We can bring an additional digital output block and send the GPIO to 6. I'll change the pulse generator so they blink a little bit faster. And I'll generate the new code. I'll flash the new code using the flash F7 command. Now we can connect to the target. And we can run the code. I'll exit the Nut shell with Ctrl+T+Q and we can see the code is still running. With Ctrl+T B as in break, the code would stop. Switching to one of our DACs is very simple. The front LED of the EMB DAC 1 is GPIO 7. We can save the model, generate the code, and plug the DAC in. Now we can flash the code with the flash F7 command. And we can connect to the target. We can run the code with main. To break the nut shell, I'll do Ctrl+T B. And to exit, I'll do Ctrl+T Q. Next time we will study digital inputs with the help of our EMB interface module. It has 4 LEDs and 4 buttons. We can now blink the LEDs.